Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Getting crunked with tech leader. I'm getting launched with tech leaders. My name is Adam Oberhausen. I'm the Vice President of Customer Solutions with Right Brain Networks, and I'm your host for today. Joining me today is my good friend and comrade and software and data consultant, Tom Kowalski. Say hi, Tom.
Hello.
Hey. And it is my honor to introduce Lancelot Carlson of House Heel Pay. Welcome again, Lance.
Thanks, Adam.
Yeah. So today this might be the last episode I do on this Agile deep dive. We'll see. There might be one more I've got on my mind where we talk about when Agile goes bad. So I feel like I've kind of ran the gauntlet here on the Agile talks, but a recap of what we talked about last time we met, which was Agile planning. We went through the whole process. We talked about that INVEST acronym. When you do story planning, that means independent, negotiable, valuable, estimable, small, and testable. We talked about how developers estimate stories using planning poker. We talked about how business folks rank the stories so that the developers know which ones to do on their sprints. We talked about how to avoid traps from overzealous stakeholders who try to get you to overcommit when doing your iterations and setting unrealistic goals. And we talked a little bit about how teams actually execute on those iterations, checkpoints, keeping track of your velocity. Was a good talk. So this time we're talking about the secrets of agile programming, and I'll start by talking about. Let me see if I can put it in the chat here for our audience. I always forget how to do this. But Lance, are you familiar with The Circle of Life by Ron Jeffries?
That sounds familiar.
Yeah, I'm going to post it in the chat here for you and the audience and Tom, of course. But, so Ron Jeffries is one of the co-creators of Extreme Programming. And, Kent Beck, of course, was a key part of Extreme Programming, and they came up with this circle of life diagram. And if you look at the diagram, it ties into this whole agile practice that I've been deep diving into. A lot of it, of course, from Uncle Bob, Robert Martin, as my inspiration for these. So when you look at this diagram, there is the outer circle, which is like the whole team. It represents like the business-facing practices. And then you look at the middle circle, it represents the team-oriented practices. And then the center circle are the programming practices. So, and that's what we're going to talk about today, is the center circle, about how the programming practices, as prescribed by my hero, Uncle Bob, Robert Martin. And those 4 disciplines are test-driven development, refactoring, simple design, and paired programming. I recall, Tom, a time in your career that you were all about the extreme programming. So I'm wondering if you had seen this diagram or, have heard of any of this.
Not this diagram, but yeah, I'm a huge fan, right? I know there's a lot more to it, but it's usually the paired programming I'm a huge fan of, right? That's a big part of the extreme programming. But yeah.
Yeah.
There's also test-driven development, right? Is that part of it?
Yeah, I said test-driven development, refactoring, simple design, and pair programming are the 4 kind of programming practices that are part of this inner circle of this circle of life diagram.
So there is some controversy, I think, in programming circles around whether or not to do TDT. I think that's like of the things mentioned is the most controversial.
Yeah.
And then paired programming is maybe the next.
Definitely a lot of controversy. So yeah, I drink the Kool-Aid, right? I've seen the light. I think test-driven design development is a great way to approach software development, and I'm going to state my case, and I want to hear what you guys think. But let's start with the three rules of test-driven development, which are, let me pull up my notes here. The first law: no production code can be written without a failing unit test. The second law of test-driven development: write only enough of a test to fail, including compilation failure. Third law is write only enough production code to pass the failing test. So it seems very impractical, I think, to take this approach. It just sounds stupid, right? Let's just be honest. I mean, you're supposed to, you write a piece of code, piece of test code, it won't compile. So then you have to go to your production code and write that until that test pass. And then you go back and write another small piece of test code, and then it fails to compile or run, and then you just kind of keep going through the cycle over and over and over again. It seems insane, but it actually aligns with another practice, and a very important industry. I'm wondering if you guys could think of like another career or discipline where this type of approach kind of work in a similar fashion of this like iterative loop of like always kind of, writing test code, production code, this cycle. I'll share it with you, and it's accounting. So accounting about 500 years ago came up with the system of double booking, right? And it's and accounting is a lot of ways similar to programming. There's a lot of formulas, bizarre symbols, exact syntax. In order to do it in accounting, they use the double entry booking. And so everything that's entered goes into the asset side, and then once on the liability side, and then it follows a separate mathematical path, and then it always equals zero. So the analogy there is that test-driven design follows that, a similar pattern, in that you're writing, everything gets entered once on the test side, once on the production code side. They follow a complementary execution pathway, and they wind up at zero defects. And so the idea is that every line of code has a 100% test coverage. I'll stop there and just see if you guys have any thoughts about, Lance, you said there's some controversy around test-driven design. I'd like to hear, what your thoughts are, and had you ever heard of that comparison between accounting and the double booking with test-driven design development?
No, I don't think I've heard of this is the first time I've heard about the bookkeeping analogy. It's a good one.
Yeah.
I think the largest part of the controversy is centered around test-driven development when it refers to doing tests first. I don't know if there's any version of TDD that doesn't say you need to write tests first, but I think that there's a group of people that say you should write tests. I am fully on that train, but there's a group of people that don't agree with having to test first.
So are you saying these people say they write a lot of production code and then go back and write tests, or are they just saying they write production code first, or a small line of production code and then a small line of test code? Because that's
I think they don't want. Well, I mean, I think the constraint is hindering some people, I guess. Like, people want to be able to write a bunch of production code and then be able to write the test afterwards. I think as you become a more senior developer, you kind of know your design and want to kind of flesh that out first, maybe, and then put the tests in afterwards to sort of make sure that you're not violating that interface that you've created.
Yeah, I think what you just said there kind of hits on my experience. And it depends on what you're programming, right? If you have everything like established and you're just adding, a feature to a pattern that you already know, right? It's a little bit easier. But most of the stuff I do when I'm programming, I don't know what it even is, or what these objects are, to even think about what the test case is. And that's kind of where I have issues with this, right? And you said too, like unit testing, and I don't agree that everything needs to be unit tested. So I think that's kind of the issue where, if you're just doing, sometimes with translations, but a lot of times, you're just adding something that, unless there's business logic that you're doing, and sometimes you don't even know what those objects are that are used in that business logic. So those are kind of the issues that I've had in dealing with that. So, yeah.
But I do think that when you're a junior developer just starting to learn these things, it is useful for you to run through the exercise of trying to test everything first, because you then you really understand, like, when someone says, oh, I think I'm writing useless unit tests, like, you can actually clarify that distinctly, because when you've written useless unit tests.
Yeah. It's something I wanted to follow up with Tom, with both of you. I think, you said, like, sometimes you're writing code and you don't even know, like, what the objects will be, right? To me, as someone who, like I said, believes the dogma now, you start with like, okay, this object is null, like, it doesn't even exist, right? Like, your test starts with, like, can you instantiate the object? As you add methods and properties to that object, there's a little line of test code for each of those little things you add to those objects. So I think you start with, like, and then there's a lot of refactoring involved in this whole process, right? So, like, and that's our next topic that I want to transition to is the refactoring part.
It's interesting because I have a lot of interest in sort of writing stories for movies, script writing, and it's kind of interesting. And in that, you kind of also have to look at story writing in regular books, and it's kind of interesting to compare and contrast the experience of writing a story from the characters first, the individual characters, versus trying to compile the story first and then sort of create characters from that. And so it's like, when you don't know what you're building for and you're exploring, sometimes starting from the characters first can actually be bad, because you don't know. It can be difficult to stitch things together. And my comparison here is like objects, right? When you're in classes, sometimes, like, you're kind of creating classes in this lower level of abstraction, lower than you should be, and you're writing tests for it. And then you realize you have to throw it all away later because that wasn't the correct abstraction. And, you should have just been prototyping.
Yeah.
Yeah.
Yeah. Sell us here, Adam.
Okay. So, all right, here's the statement. Okay. So if test-driven development, if you follow that, it allows you to quickly and easily refactor your code without fear. If you look at a team that starts a greenfield project, right? Say they're starting something brand new, and let's say in this example, they're not using test-driven development. So at the beginning of the project, they're going to go really, really fast and get a lot of stuff done. But as time passes, they slow down, and they keep slowing down to nearly a crawl, because the code gets messier and messier and worse and more tangled. And, they don't know all the dependencies, and, maybe even if it's written cleanly, it's just like that the challenge it takes to refactor basically can prevent the team from moving forward. Whereas if you start with a good test-driven development discipline, and it allows your team to maintain that same level of velocity, because there should be no fear in rewriting your code, because you should always be refactoring. Refactoring should be happening with every iteration of your test-driven development. It's not something you don't put, like, refactoring on your project roadmap, like, oh, let's refactor this, this system. It should be part of your daily 5-minute cycle of test-driven development. So yeah, there you go. And if you want to be able to maintain your velocity and have no fear of changing your code, I think about some of the systems we developed at our previous job, Tom, and it's just like, there was just a lot of there was really no there was really no unit test in majority of the code base. And so it became really difficult to change code without understanding its impacts.
Yeah, it's just also hard too, because usually when you're refactoring, it's like a different way of doing it, right? A different object done differently, right? And the tests don't coincide anymore, right? Like I'm now moving this logic over here, and it's like, well, now that the test doesn't even, I can't even run that test the same way anymore. I always feel like whenever I do test driven, it's like, yeah, I'll start off with, here's some assumptions in the test. And then as I'm making changes, sure, it breaks the test, but then it's like, I just keep refactoring the test just to match it. And it's like, I'm doing double the work for most of the time.
Yeah.
And really the thing you're striving for is to build a system that is easy to change.
Yes. Software versus hardware. Hardware is it's mutable or immutable. Software is, by its definition of its name, soft. It should be easy to change. So a couple of other analogies I came across is just when it comes to refactoring, and you might get feedback from stakeholders or your manager that we don't have time to refactor or this or that. I just think about an author who writes a book, Tom. Like, you think an author starts at page 1 and just writes all the way through to page 300 and then the book's done, right? No, I'd imagine there's this iteration and refactoring as they develop characters and figure out where to insert, other things into the story. The same thing with scientific research papers. A composer who writes a symphony, they're not just writing note by note perfectly. There's a refactor. It's a sign of good work. And I know you're not saying that you're against refactorings. I'm not trying to imply that, but there's all these other analogies in almost anything that you would classify as good or interesting work. Refactoring is a big piece of what people do in almost every discipline. So as developers, I think it's important that, oh yeah, okay, so yep, oh well, so you refactored some production code, yep, you got to refactor the tests accordingly. It's all worth it in the end.
Yeah, there's an interesting concept of tracer bullet development, which is, I like to, in this case, my analogy is going to be some script writing. Actually, they start from the end of the story. So they're like, how do I want this story to end first? And what's the cognitive effect I'm trying to achieve? So you could kind of do the same thing with programming, where it's like, well, this is the end result I want. Maybe you even create some sort of integration test, and then you can build the code towards that, assuming that's the intended result at the end of it. Actually, I'm a huge fan of integration tests when you do know what you need to do.
Okay. Yeah, so that's my take on refactoring. And that leads us to the next piece of the circle of life, inner circle there, and that's simple design. Again, this can be a controversial aspect of agile development. And I learned about a new acronym called YAGNI. Anyone ever hear this? YAGNI, YAGNI. You aren't going to need it.
Yes.
So this is the idea of putting in hooks or scaffolding for future ideas or future features. And it's a bad idea. And the reason it's a bad idea is because of Kent Beck's 4 rules of simple design. And again, I'm drinking the Kool-Aid, so here they are. Kent Beck, he was very much involved in all these players I like to talk about: Agile Manifesto, XP, Extreme Programming. Worked a lot with Robert Martin on things as well. So the 4 rules of simple design are the code that passes all of its tests, code that reveals its intention, code that has no duplication, and code that contains the fewest number of elements. So when you look at rule number 1, code that passes all of its tests, it seems like it implies that you have to be doing test-driven development. If you're not, you kind of have these barely baked test suites that could pass on a rainy day, and you don't really know the state of your code. So in order for the rule as it's stated is that in order for you in order for your design to be simple, it has to pass all the tests. It has to be proven that it works as intended.
So my brain is really kind of struggling on something. It's just like an internal conflict. This Yagni versus dry. There's like for me as a programmer, this comes up all the time where it's like I'm developing a feature and I'm doing well with it, but then I'm having to consider the fact that this feature is going to look a lot like another thing that I need to do. And so do I create an abstraction now, or do I wait until I'm developing to support that other thing as well? And that is, those things are always in conflict, I think, for developers. And a specific example that came up more recently was that I wanted to support synchronization of GitHub and GitLab commits. And so I've started with GitHub, and that code is now working for GitHub, but now I have to support GitLab, and how much of that translates over. Turns out not a lot as far as the actual integration code, the adapter code, but the abstraction, there's a layer there that could be abstracted, but do I need to do that now? I don't know.
So that hops to the last rule of simple design, where the current code should contain the fewest number of elements. So if you're following this by the book, you would say, no, you shouldn't, because Yagni says, that we don't want to add things in anticipation of future code, because that makes the current code not as small as possible. But I will say, if you're adding hooks or scaffolding for future features because you fear that your code is going to get too complicated down the road, that's when you're doing it wrong, right? If you're starting out the project and it's like, well, I just know it's going to get really complicated 3 months from now to add this in later, so we want to add in the scaffolding now. That's the no for me. That's when you should say, no, halt, deceased, do not proceed with this line of mentality.
And
whereas your case, Lance, like, I don't know. I think there's always gray area with some of these rules.
Well, and then I guess it's like the timing of deployment, right? So if you're being forced to deploy this feature, half of it, and then you're going to have to support the second half of this feature later, it's going to be a pain in the butt to migrate your database to the other version. Yeah.
So.
There's a lot of trade-offs. It's it depends. I think that's what helps to have the who's ever working on this to be as close to the problem and problems going forward as possible to be able to make that decision, and then to also be conscious of it. Don't always try to do not repeat yourself or any of those. Like, don't treat them as dogma, right? But keep them in the back of your mind as, okay, should I be abstracting this now? I think it's always good to think about it. But don't always jump to the over abstraction in the beginning. But it's always good to at least think about it. I like to say that the 10% of your time thinking about what that future is, because you don't want to get hung up on it, but you could really shoot yourself in the foot by making some decisions up front that you could have saved a lot of time down the road. So I always say you got to at least think about it. But don't over abstract. That one rule that I like to do is, even if I'm writing it twice, right, I still don't really abstract, but it's like the third or fourth time is when I think, okay, that's because even when you do it that second time, you still don't know. There's things that could still be the same between them, but it's that third, fourth time. It's like, okay, now it's time to abstract this. It's a rule that I use.
And I think that's where this conflict with test first development comes into play, because I think that when you're doing test first development, you're encouraged to create unit tests and develop at that lower level of abstraction, when really you should be thinking at a little higher level of abstraction. And at the lower level of abstraction, if you're stuck there, you're sort of thinking about all the different ways that this small little class could be, useful in different contexts when, Yagni, right?
Mm-hmm. Yeah, that's a good point.
Yeah.
It's like sometimes these rules conflict with each other.
Mm-hmm.
So when we talk about simple design, we're not talking about stupid design. So what that means is the attribute of simplicity does not mean that we're talking about code that's simple to write, right? Because writing simple design can actually can be very hard to write code that follows these rules. So I think it's just, in the research for the show, it was like, oh, well, if I just follow these rules, I don't need to think about architecture or design. I just need to follow these rules and everything will be great. And it's like, no, that's not it at all. Like simple design is actually very challenging to adhere to. And when we talk about simple design, we're talking about code that's testable, it's understandable, it's as simple as we can make it, and it's as small as we can make it. So it's kind of my final thoughts on the whole simple design. And the big thing that you hit on Lance, is simple design implies that it's easy to change at a future date when it needs to be changed. So, there's one thing that's true about software, is that software cannot be done correctly. It cannot be written correctly, but you can correct it. Okay. So
Simple design is also not simple.
Yeah. Yeah. Just a lot of paradoxes and everything we're talking about today.
Mm-hmm. Mm-hmm.
Okay, so the last pillar of this inner circle is the paired programming. So some might say this is the most misunderstood of disciplines. And just to give a little explainer of what it is, paired programming is the practice of two people working together to write a single stream of code. They can work together on a line-by-line basis, character by character. You can work at a single workstation where you share a screen, keyboard, and mouse, or you can work, there's like single workstation with dual controls. You can do independent workstations with screen sharing over remote. So there's all kinds of ways that technology can help facilitate this. But the big point is that you've got two developers interacting with each other second by second on individual lines of codes. So they're basically co-authors of the code being produced. So start with a question. Why would we even want to do paired programming in the first place? Anybody?
Lots of good reasons.
What are they?
Information sharing is a big one.
Ding, 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 ding. That's right. That's the most important one, in my opinion, because if you use the sports team analogy, if a player goes down, you need the other players to be able to pick up the slack. So that whole knowledge sharing and domain sharing makes it so your agile team is more well-rounded. People understand all the components of the application. You're breaking down those knowledge silos. So yes, I would say that is by far the biggest reason to do paired programming.
Yeah, I think in terms of information, you should have as much as you can asynchronous. But with the paired programming, there's that little bit that you don't think about, right? And you wouldn't unless you were paired programming, and not just the what the app is, right, and how it's working, but more of the how to work on it, right? The tools is the biggest thing that I love when working with somebody else and seeing how they interact, moving from screen to screen, or the different tools, different things like that is a big one in the knowledge sharing, not just so much the app but the process.
Yeah, opponents, people that maybe aren't pro paired programming would say, oh, it's gonna decrease productivity, right? It's gonna cut the team's productivity in half, which is absurd.
It's a great training vehicle.
Exactly.
One of my first sysadmin jobs, I thought I was pretty good at command line. I was pretty good. I use Linux a lot. But when I saw my boss flying through the terminal, running, literal hosted machines, just, increasing and decreasing RAM and just orchestrating the world, I was opened to a new reality of what was possible. And I was like, I need to get there. And it only took from there, it only took maybe 3 to 6 months, and I did a lot, but I only paired with my boss maybe the first, 2 weeks of my coming on board. So.
Yeah. And just that little bit of, guidance and inspiration from a senior person was able to kind of show you what another human is capable of, right? That you may have not, even known about until you saw it in real life.
Mm-hmm. I think the other thing too, the conception, and when people hear it is like, oh, like all of my programming, right, is going to be done this way. I've never seen that, right, where it's every single line by line is always written by paired programming. It's usually split up, right, certain percentage, or if you're working on something new or whatever. But I don't know, is there like a prescriptive guideline that you've seen, Adam? It has to be this much, or
So great question, Tom. So agile teams who pair and mature agile teams always pair, will pair maybe 50% of the time as a good baseline. It can be lower or higher. It says in my notes, in my research, that if you're pairing 20% of the time, it's probably a little too low to get the knowledge share you need. But I think 50%, and they should be pretty short sessions, like 1 or 2 hours tops. Couple Pomodoros, if you're using Pomodoro technique, which is a great technique to do paired programming. And I wanted to circle back to what you said, Tom, about the benefit of paired programming is not that you go faster, right? Typing your programming words is not the bottleneck when you're programming, right? It's your mind. Your mind is the bottleneck. So when you bring another mind into that process, I'll just throw out the metaphor, 2 minds are better than 1, right? So like that's where you see the benefit. There's actually some data around paired programming, and the statistics are very interesting, and I'll share them with you. So some studies have shown that paired programming suggests that paired programmers will suffer a 15% loss in instantaneous productivity. Instantaneous means measured over an hour as opposed to measure over a week or a month. So I don't want to dive too far into that. I'll move on to the next one. We'll circle back to it. The number of defects they produce over an hour will diminish by 15%. So that's good.
I'll say it's even higher. Okay.
Yeah, I would say I would have thought it would be higher. And then the number of lines of code they produce will diminish by 15%. So that's a good thing too. So I think, you could look at those statistics and think that there's a loss of productivity, but fewer lines of code means that implies a better design. Fewer defects implies a better design. If you're measuring productivity by the number of lines of code, your whole business model is wrong, and you need to rethink your whole life. So,
yeah, just talking about simple design, yak shaving.
But all statistics aside, the benefit of paired programming is the teamwork aspect of it. Your team is maturing. You've got senior developers pairing with junior developers. You could have juniors pairing with juniors, but you want to monitor that closely and make sure they're not driving each other off a cliff. You could have seniors pair with seniors, but that can be, you gotta be careful with that too, because you want to make sure there's not some that could lead to a fight about just like the right way to do something, right? Or it could lead to bigger arguments about the whole design of the system, which I thought was an interesting thing to think about. But I've never actually seen senior developers who are pairing getting in like verbal altercations.
I think you have other issues than.
Yeah.
I think you have to be very deliberate about who's driving and who's passengering. And there's a lot of psychology that's built into the being a driver versus being a passenger, especially in the senior developer to senior developer case. You have to, and that kind of develops over time as you do it more and you experience different personalities. But knowing when to chime in and not interrupt someone's thought process, even, they might be quiet for some reason, and you guys kind of develop a language with each other to figure out what that is and when to interrupt. it's an interesting psychology to think about.
Yeah. Are there any statistics on that as the driver versus passenger? I love to be the passenger, right? I'm not a fast typer. Usually, I like to pair with more senior developers, engineers, right? And learning the tricks, and they type a lot faster, whereas that I can sit back and think about the design more, like as they're typing a lot faster. So I tend to want to be more of the passenger at a lot higher percentage. But yeah, that is interesting. Do they say like it's better to switch and be or 50-50 all the time, or is it kind of
I have no data on that.
yeah.
I think in general, trying to, I mean, it depends on your goal. If you're the more senior person and you're trying to train the other person, you might start off by being the driver in the very beginning, and then completely flip that around towards the end as you're making sure that your co-pilot is familiar with their environment and what they're trying to do in real time. When it's senior to senior, I think more of an even split is better. I mean, it's funny because even small things like making sure that your environments are both set up properly for that particular ticket, whether it's like your database being in the same state or whatever it is, can be helpful. Especially if you're doing a hybrid approach where you kind of go off and start programming by yourselves. It could be nice to make sure that this is your checkpoint and you're both on the same page. That's my experience.
A lot of depends, right? It's good to talk about this and know the different ideas of what's better and but it's a lot of it depends.
So Lance, I want to circle back to the beginning when you said that some polarization around test-driven development. If people aren't using test-driven development, what are they doing, and then how do they keep their code so that it can be easily changed and adaptable without breaking a bunch of stuff?
Well, I do think that having tests is important, and I don't think that the measure of coverage, the percentage, is necessarily a metric that is accurate. But I think that having the basic business logic covered in tests should be there. And how you end up there is not as important as having it before you release to production and you've pushed the code to your CI build system and have it run through the tests and make sure that you don't run into the, hey, it worked in my machine issue, because you want to make sure that it's working on the Docker or whatever environment that you've set up on production system as well. So you're not running into issues when you do try to push this to production. So general rule of thumb is we still need tests. I still think that at the end of the day, you want those tests, but you're not necessarily writing all those micro unit tests ahead of time and doing that pass green fail system where you're in this infinite loop of your feedback loop is the tests. Maybe your feedback loop is the design, and you're just trying to write it out.
I think it really depends too on like the language you're using, what frameworks, right? How well established it is. There's a lot of frameworks or even languages that make it a lot easier to do this up front, right? If you have more of a functional language and things are, your business logic is almost always done in pure functions and you have side effects, it makes these a lot easier to do. Or if you have frameworks that make it easier, just, here's a button press and generate those failing tests for me, can also be useful. So yeah, it depends. And just your flow and culture, right? Do you like have a team that will help you with these, right? To do like they call the three amigos, right? Where you sit down and go over, the different actions and the different frameworks, right? The cucumber, and I don't remember all of them, right? That, I think it depends on the different frameworks, the language you're using. what makes it easier to write the tests, how and when they get written.
Yeah, and I mean, I think that it's super important that the developers are talking to a designer or a product person as well, because you're going to get more of the information, the business logic there. If you screwed up the business logic, but you were writing tests, like that's a failure. That's like, I just think there's a higher level of abstraction that you should be more focused on, because if you miss that, there's no amount of tests that are covering what you did.
Alrighty. Well, great talk today. Want to thank all of our listeners for tuning in today to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable. Love to have you join us again next week, where Jason Brown and expert co-hosts are going to be discussing security strategies for serverless development. Be sure to tune in, because it's going to be one hell of an emotional roller coaster, Tom.
Woo! Yeah.
All right. Thanks, guys. Talk to you soon.
Thank you.
Thank you.
Bye-bye.